Okay, we are now doing the heteroscedasticity. So first thing we need to do is click on data, then data analysis. Sorry about that. Recording now, heteroscedasticity, we're running the regression. And the Y is the quantity. As you can see, it's already highlighted. The X is the first two columns all the way. So we run the regression. Now, what we want to do is we want to look at mostly the residual plots, but the line fit plots sometimes can be helpful too. If you look at the residual plot for price, and for income both, you see that the farther to the right get much more variation than to the left. So it looks like we got heteroscedasticity in both. I personally think that because of this center area being fairly constant and that being fairly wide, that this shows more of a heteroscedasticity. So I'm going to say that price has it. My guess is if I ran both, I'd find that both of them have it. So the first thing we have to do is highlight all of these. And we've got to sort. So we got to go back to the Home tab, sort. I always do custom sort. Going to choose price. Now it's all sorted based upon the price. Next thing we have to do is divide this into 35%. So we have, last line is line 41. That means we have 40 data points. So we got to take 35% of that. So 0.35 times 40 equals 14 exactly. So we're going to want to break this up into two groups of 14 data. The first group and the second group. So we will now run another regression. If you look, you can see that it says I've highlighted 15 rows. That will give us 14 data points. "15 rows gives us 14 data points. New page, top. Make sure we have 14 observations. We do. Now we go back, run a regression with the bottom 14. Now here, because there's no header, we only want 14 rows. And we have to uncheck labels. Got to change this to bottom. Make sure you still have 14. The important thing is that both have the same number. If it had been like 14.3, you could have chosen 14 or you could have chosen 15. The exact number is not important providing they are the same. So what we want to do is we want to take this sum of the squares of the errors for the residual, copy that from the bottom and put it over someplace like here. I did Control C to copy, I'm doing Control V to paste, and I'm going to label that bottom. So now we're going to find the F. The F is going to equal the bigger of these two numbers, the bottom SS residual or the top. In this case, it looks like the bottom's the bigger one, divided by the other one. Gives us 17. If you get a number less than 1, you've got the fraction upside down. Then we do the significance of F. This equals F. Now, there are two ways to do this. The way I like is the f.dis.rt. Your x that you want to do is the F. Degrees of freedom is 11. And the degrees of freedom of the other one is also 11. Notice that that is far less than 0.05, so we clearly have it. Definitely have the other way you could do it equals F do.dist. Take the F. Then we take the degrees of freedom, 11, 11, 1, because we want cumulative. And actually, we want to do 1 minus this, but I'll show you what this does. Notice that that's 0.99997. Well, if you add that number to the number above it, you get 1. That says we've done it correctly, but what we want to do is you want to have 1 minus. It gives us the same value. Since we use the same cutoffs as significance of F, so that is highly significant that we have heteroscedasticity. Heteroscedasticity will just mean the size of your errors is going to be off, but it's not going to bias the coefficients. To fix that, you need much more complicated software.